Hello students, welcome to your geography class, and today we will start with chapter 4 of fundamentals of geography, that is distribution of oceans and continents. Now in this chapter we are going to learn about how the oceans and continents were formed, what were the various ways in which, what were the various evidences that has been found regarding the formation of these oceans and continents, and then we would know about the various stages, various divisions of the oceanic floor, and definitely about the volcanic earthquake and volcanic zones. Now let us start with the continental drift theory. Now what do you understand by this continental drift? Now continental drift theory refers to the theory in which Alfred Wegener has explained how the continental plates have drifted in course of time, right? And how and what has it resulted in? What has happened due to this drift in the continental plates? Now, this continental drift theory was first supported by the German meteorologist Alfred Wegener, and it was he propounded the theory. According to this theory, there was only one continent earlier, which was known as Pangaea, and there was only one ocean, mega ocean, which was known as Panthalassa. The supercontinent Pangaea began to split into large continental masses called Laurasia and the Gondwana land, which eventually broke into smaller continents that we have today, that exists today, right? So what does the theory of continental drift suggest? It tells us that initially the entire earth was divided into one. There was only one landmass throughout the world, which was named as Pangaea, and the only water body that remained here was Panthalassa. Later the Pangaea got divided into two parts, right, which were known as Laurasia and the Gondwana land. And finally, again after that, Gondwana land broke into further divisions, and thus Gondwana land, Laurasia both broke into further divisions, and thus we have the continents as we have today. Okay, now see students, if you see, it was around 225 million years ago, we have only one supercontinent known as the Pangaea. 200 million years ago, two different parts started taking form, Laurasia and the Gondwana land, right? It was around 200 million years ago. And from this thing, we have the present day Earth, or the continents as they are today, right? Now, earlier, initially, there was only one supercontinent called Pangaea, and this water body, there was only one water body. See, everything was joined together. It was known as the Panthalassa. The place where we have the northern plain now in India, there used to exist a huge sea called the Tethys Sea, which was definitely a part of Panthalassa. Now, the previous picture that you saw, they were around 225 million years ago, and then you have 200 million years ago. In these places, in these pictures, you would see how the continents looked 135 million years ago and 65 million years ago, and this is our current continent, the condition of our current continents. Now see, here if you see, the continents have already started taking shape. They have already started forming, right? This one is Europe, this one is Asia. Here you have Africa, right? This is South America, and here at the bottom you have Antarctica, and here it is, this one is Australia, right? And see, here you already have all the parts. Now, how can you prove that the continental drift theory is correct? That is, the continents have broken, and they initially belong to one huge landmass. How can you prove that? Now, if you see, still now it looks almost like a jigsaw puzzle. See the coast of Africa and South America. Africa and South America. See, this is almost like a jigsaw puzzle, which if you bring close, they would be attached, right? And then see this part. Here also, this place. Here also, it shows that the place was initially a part of one land mass. Then this part seems to fit at this place. This Australia seems to be a part of Africa. So all this proved that the entire world had only one land mass. Now, the second part of this chapter will tell us about the various evidences that will support the continental drift theory. The first part is matching of the continents, which I have already shown you. It says that the shoreline of Africa and South America match each other. Many other continents have a coastline which match exactly like a jigsaw puzzle. This proves that the continents were joined together. Second point is rocks of same age across the continents. You will see, according to the radiometric dating, that is radiocarbon dating, carbon dating method, the belt of ancient rocks of 2000 million years of Brazil matches with those from Western Africa. Brazil, South Africa, it has South America, it has paths. Those rocks were also found in Africa. Whereas marine deposit refers to the deposits that is found on the ocean floor. Whereas marine deposits along the coastline of South America and Africa are similar. So what you find along the coastline of South America is very similar to what is found in the coastline of Africa. Tillit. Now what is tillit? It is the sedimentary rock formed of glacial deposits. When the glacier comes down, it brings a kind of sediment. That sediment is known as tillit, right? Now, the Gondwana system, sediments from India is found in Africa, Falkland Island, Madagascar, Antarctica and Australia, which proves the drifting of continents. So, the Gondwana land deposit, which is found in India, is also found in Africa, Falkland Island, Madagascar, etc., which proves that perhaps all the landmass belong to one single continent. Placer deposit. There is a rich placer deposit of gold in Ghana coast with no source of rock. The gold-bearing veins are placer deposit are the deposits which gold deposit or any kind of mineral deposits which are brought down by the river. So in Ghana, you have the placer deposit of gold, but there is no rock which contains gold. What happens in placer deposit? How is the placer deposit formed? Now, when a river passes from rocks which contain, say, gold, then it brings down gold and silver with it. But however, you can see that in Ghana coast, there is gold deposit. But however, there is no source rock from which it has brought. So the gold-bearing veins are in Brazil, and it's obvious that the gold deposits are from Brazilian plateau. Now, next part that we will study is reasons behind the drifting of plates. Why did the plates drift? According to Alfred Wegener, he believed that there are two forces which has resulted in the division of these continental plates. What are those? Pole fleeing action, pole fleeing force and tidal force. These are the two forces which has resulted in the drifting of the landmass. The pole fleeing force is caused due to the rotation of the earth, whereas tidal force is caused due to attraction of moon and sun, which is very, very minute, and most of the scientists disagree that these can be the reasons behind the drifting of the continental masses. The modern theory, however, is something else. Modern radioactive decay and residual heat generates heat within the earth, which causes the heated material at the. Now this is because of the convection current. What happens here? At the bottom of at the center of the earth, there is molten magma, right, which is extremely hot. At the asthenosphere part, the lower mantle is extremely hot and molten. The upper mantle is relatively cooler. Now what happens is the lower part, which contains of the molten magma and is extremely hot, it tries to it becomes lighter, and the upper part, which has become cold, it becomes heavier. Being heavier, it sinks down, and the hot matter from below, being lighter, it goes up. Thus, a constant convectional current is created, which has resulted in the movement of the plates, and the plates are still moving. We don't know how the continents would look after, say, 20 million, 30 million years afterwards, later, right? So the continents are still moving, and with their movement, the continents, the entire world is taking a different shape. Perhaps 50 million years later, we would find the continents in a different shape. So, what does the modern theory state? Radioactive decay and residual heat generates heat within the earth, which causes the heated material at the bottom of asthenosphere to rise up to the surface. After that, the overheated rock spread on the surface and begins to cool and sink back into deeper depth. The cycle is repeated again and again. This generates a convection current or a convection flow, which results in the movement of the plate. This theory was propounded by Arthur Holmes and is supported by most of the modern scientists. Right. Now, next is rate of plate movement. What is the pace? What is the speed at which these plates are moving? The Antarctic ridge moves at the slowest rate, less than 2.5 centimeter per year. The East Pacific rise in the South Pacific moves at the fastest rate, that is 15 centimeter per year. So the plates are moving, as I've told you. The division in the ocean floor. Now, ocean floor has also different parts. What are those? The continental margins. Continental margins refer to the coast, just beyond, a little deeper than the coast. These are the transition zones. Actually, they are the transition zone where the land ends and the sea begins. These are the transition zones between the continental shores and deep sea basins, and include continental shelf, continental slope, and continental rise, continental deep ocean trenches. Now, next we have abyssal plain. These are extensive plains which lie between the continental margin and mid-oceanic ridge. The continental sediments which move beyond the continental margin are deposited here. So anything that comes down from the continental margin gets deposited in abyssal plain. Next we have mid-oceanic ridge. Underneath the ocean also there are mountain and ridges. This is the longest mountain chain on the Earth's surface, submerged under the ocean. Now, which are the major plates? They are Antarctica, North American plate, South American plate, Pacific plate, India, which consists of India, Australia, New Zealand plate, Africa with the Eastern Atlantic floor plate, Eurasia, and the adjacent oceanic plate. Now, and the minor plates are Cocos plate between Central America and Pacific plate, Nazaca plate between South America and Pacific plate, Arabian plateau, mostly the Saudi Arabia, Philippine plateau between the Asiatic and Pacific plate, Caroline plate between Philippine and Indian plate, and Fuji plate between Northeast and Australia. Now, distribution of earthquake and volcanic zones. Now, as you know, the volcanoes and earthquake, they are widely distributed. The earthquake mostly occur in weak coastal areas of the earth. Now, these are the two belts, Circum-Pacific belt and mid-walled mountain belt. Circum-Pacific belt, about 68% of world's earthquake are observed along the coasts of vast Pacific Ocean. This is known as the Ring of Fire. This is the area of intense volcanic activity also. So this is the many volcanic mountains are situated in this area, and it is known as the volcanic ring of fire. Chile, California, Alaska, Japan, Philippines, New Zealand and the mid-ocean areas have had many minor and major earthquakes in this belt. Mid-wall mountain belt, nearly 21% of the world's earthquakes occur in mid-wall mountain belt. It extends parallel to the equator from Mexico across Atlantic Caucasus ranges to the Caspian Himalayan mountain and adjoining lands. This zone has folded mountain, large depression and active volcanoes. Finally, the minor belts, the remaining 11% of the shocks means here it refers to the volcanic shocks, the earthquakes are recorded outside these two belts. So maximum earthquake occurs in these two belts, mid-oceanic ridge and circum-Pacific belt. Circum-Pacific belt and mid-walled mountain belt. And in the minor plates we have very little shocks. The remaining 11% of the shocks are recorded outside these two belts. Only a few occur along the fracture in African lakes, Red and Dead Sea zone. Right? So this is all about the chapter, students. I hope everything is quite clear. I hope you will be able to answer the questions. Refer to net and refer to the notes, refer to the discussion that we have today. Thanks for today. Goodbye.